Spatial Economics. Spatial economics is addressing the relationship between economy and its spatial component. In this movie, we will give you an overview about the von Thun model, the bit rent theory, the theory of central places, the core periphery model, and the racetrack economy. The von Thun model is an abstract zoning model to define locations of agricultural land in order to maximize the revenue of all products combined. It is from the year 1826. Imagine an isolated and geographically idealized state with no outside impacts like neighbor countries for trades. In the center of the state is the market, to which all the produced agricultural goods are delivered. The quality of the agricultural land is uniform, and the transportation costs are fixed because there is only one transportation method. As already mentioned, the von Thun model is trying to maximize the total revenue of all agricultural goods in the state. To illustrate that, we assume that there are only two products produced. They are defined by the price they achieve on the market and their transportation cost. The wheat is achieving a low price on the market, but due to its light weight, is also cheaper when it comes to transportation. The wood is more expensive, but also heavier, what makes it costly to transport. The revenue of each product is therefore the difference between its price related to transportation cost. If we look at this relationship on a coordinate system, we see that the revenue is decreasing as a linear function the further product has to be delivered. The wheat is starting with a relatively low revenue, but it's only slowly decreasing over distance because of its low transportation cost. The wood, on the other hand, is starting with a high revenue, but is decreasing much faster due to its high weight. This means the wood is generating a higher profit on the market, but only until a certain distance, when the transportation costs are consuming too much of the profit. The point where the two functions are intersecting is where the revenue of the wood is turning and the former cheap wheat is generating a higher profit. This point is therefore the distance to the market until and from where it is more profitable to cultivate one or the other agricultural product. This spatial relationship is producing the radial zonings for different agricultural goods related to their revenue. They are named after Johann Heinrich von Thun.
The bit rent theory is a geographical economic theory that refers to how the price and the demand for real estate change as the distance from the central business district (CBD) increases. The diagram shows what various land users are prepared and able to pay for good access to the CBD. Green line shows commerce, red one industry, blue one residential land that are willing to pay. As von Thunen's lead concentric circle, Alonso also used circular model. This theory is based upon the reasoning that the more accessible an area, the more profitable. That's why commerce agglomerate to CBD even if it is high rent. Industry is, however, willing to pay to be on the outskirts of the CBD. There is more land available for their factories, but they still have many of the benefits of the CBD, such as a marketplace and good communications. As you move farther out, so the land is less attractive to industry and the householder is able to purchase land. The farther you go from the CBD, the cheaper the land. This is why inner city areas are very densely populated, like terraces, flats, and high-rises, while the suburbs and rural areas are sparsely populated as semi- and detached houses with gardens.
The central place theory is a model to explain the distribution of cities of different sizes. It is based on spatial studies in the south of Germany in the 1930s by Walter Christaller. Similar to the von Thun model, we start from central place. But in this case, the city is not consuming but producing some kind of product. In order to produce economically, a certain threshold has to be reached. Means that there must be a minimum amount of customers buying the product. This is due to the centralized production method like manufacturing, which is able to produce products for a lower price but in a large amount. But this catchment area is also limited by the demand and the consuming behavior of the customers. This behavior is highly dependent on the amount of resources one has to invest to purchase the product, means the time and the amount of money one has to spend. In other words, the longer someone has to travel to buy the product and the higher the price for the journey, the less likely it will be that this person is buying it. This is then the maximum catchment area, which is also defining the degree of centrality for a place. If a customer is too far away from the central place, he is not supplied with the product anymore. This means he must be in the catchment area of another central place producing the good in order to buy it. Having a zoomed out look on the distribution of places in an area, it becomes clear that a bigger amount of central places is necessary to supply all the settlements outside the catchment area of the first central place. To provide a gapless supply with a product of the same centrality in an idealized model, 6 further central places have to be placed circular in a certain distance to the first central city. This as a location is the most economic to cover every town without creating too much overlap of the circular catchment areas. Since customers in the overlapping areas are now in the catchment area of 2 central places, one could assume that these people would travel to the closest. The result would be a straight line between the intersection points of the catchment areas, dividing it into an evenly hexagonal pattern. Not all products have the same centrality and therefore the same catchment area. For products with a smaller centrality, this allocation of central places would not cover the area without gaps. That means this area is supplied with long-range products but not with those of a lower centrality. For example, are people more willingly to travel to the more central place to buy clothes than to buy milk? In order to achieve a full supply, a more closely meshed distribution of cities with a lower centrality is needed. This means there must be a new central place which is providing products of a smaller centrality. To cover all potential gaps, again, 6 central places with a lower centrality are allocated around the first city. This more central place is also covering one part of the mesh and therefore products of both low and high centrality. And again, a hexagonal pattern is dividing these central places evenly. If we now add this hexagonal pattern of lower centrality to the hexagons of higher centrality, we achieve a grid with the locations of the correlating central places, whereby the cities of higher centrality support those with the lower. And of course, another reduction of the catchment area of the lower central places would generate a new hexagonal pattern. This creates a hierarchical structure of cities, which are categorized by types, whereby the smallest central place defines the spacing of the grid. Number of inhabitants and manufactured products is correlating with the size of each city.
When transportation costs, or more generally trade costs, are sufficiently low, Klugman has shown that all manufacturers are concentrated in a single region that becomes the core of the economy, whereas the other region, called the periphery, supplies only the agricultural good. For example, Korea case with a strong economy dominance of Seoul, consider two opposing forces: agglomeration forces that tend to pull economic activity towards particular locations, and the dispersion forces that tend to push economic activities away from each other. These forces drive self-organization of spatial structures. The core periphery structures consisting of the dominating core like Seoul and the less clear as peripheral regions is a typical consequence in one region. The periphery, where unskilled workers in food production provide low-wage labor and raw materials like crops, vegetables to the core constantly. On the other hand, the core where skilled workers in the manufacturing firms provide high profit value added goods to periphery with increased value. The skilled workers have the possibility to change their location, which is not possible for the unskilled workers because agricultural land is immobile. So racetrack model. So core model is only framework, so then Krugman developed the model with multiple lesions for the first time. With setting 12 cities and severe parameters, we try to figure out how these parameters affect the composition of core and the periphery. This time, we only focus two significant parameters: transportation cost and the economy of scale. Imagine when the manufactured products from the other region have some transportation cost, which makes them more expensive for the farther away region, but the manufacturing firms experiences economics of scale, which means that they have lower production costs per unit if they have mass production with more workers. This effect is called economics of scale. This time, we found Krugman's simulation program online, so from now on, I'm going to show it and explain about it. In this simulation model, 50 cities are set with slight different initial number of agglomerations since, if it is set equally, nobody will move on simulation and not realistic as well. Below, you can find two parameters with two sliders, T and sigma. T is for transportation cost, and sigma is for economy of scale. T equal 1 means cost-free, and 10 means very high. Sigma equal 1 means high effect, and 20 means no effect of economy of scale. As you can see, as you set lower transportation cost, people tend to agglomerate fewer cities. Then when you set higher the effect of economy of scale, people also tend to agglomerate in fewer cities. Simulation organizer tried millions of times to simulate and lead these results of bar chart below. As you can see, x-axis is for trade costs, y-axis is for economy of scale, and z-axis is for number of agglomeration. We can say it's getting no economy of scale, like from airplane industry, then car industry to clothes industry, the more significant effect of trade cost to the agglomeration. So transportation costs strongly influence the small economies of scale like clothes industry, while large economies scale like airplane industry doesn't be affected by trade cost.